Alright guys, now we're going to look at adding or subtracting with unlike denominators. So just a reminder that we cannot currently add or subtract these two fractions because they do not have the same denominator, 4x and 10x squared. Now think back to when you were in elementary school first learning fractions. You might have learned, 2/3 plus 1/2. And you would have had to figure out a way to make these denominators the same. So you might have said, oh, I can make them both have the denominator of 6. So if I do 3 times 2, I'd have to do 2 times 2, which is 4. And if I do, to get from 2 to 6, I have to multiply by 3. So I have to do 1 times 3. Remember, you have to keep this numerator. We have to do the same thing to the top and bottom because this is just a fancy form of 1. Okay, we can multiply anything by 1 without changing its value. And then you'd be able to add 4 plus 3, which is 7/6. That's kind of what we're going to be doing today. Okay, so if you look over here with this 4x and the 10x squared, we have to somehow make them be the exact same denominator. So to do this, we need to find the least common denominator. So when we're looking at 4x is going to be 2 times 2 times x. So remember doing that, breaking that apart into its prime factors. And then 10x would be 2 times 5 times x times x. So to find this least common denominator, we're going to start by saying, well, what do they have in common? Okay, so they have a 2 in common, and they have an x in common. So we definitely have a 2 and an x. And then we're going to write down anything they don't have in common. So they don't have a 2, a 5, or an x. So we're going to multiply this by 2 times 5 times x, which means our least common denominator is going to be 2 times 2 times 5. So 2 times 2 is 4, 4 times 5 is 20, and x times x, which is x squared. So our least common denominator is going to be 20x squared. So in order to make these both 20x squared, so I'm going to rewrite this as 1 over 2 times x plus, and then we have that x plus 3 on top, over, again, that was 2 times 5 times x. We need to figure out which each one is missing. So notice 2 times x, it's missing this 5 and this x. We need it to be 20x squared. So we're going to multiply this one by 5x on top and on bottom. Okay, and again, notice that's what's missing here. That was the 5 and the x in the second term. Now on our second fraction, well, it already has a 2, a 5, an x, and an x, right? It has 2, 5, x, and x. All it's lacking is an extra 2. And notice we can see that 2 right up here when we broke it down. So times 2 times 2. So now we're going to simply simplify this down. So on top we have 1 times 5x, which is 5x. 2 times 2x times 5x, of course, is that 20x squared that we just found over here. Okay, so if you're having a hard time seeing that, there you go. And then plus, now we are going to distribute this, 2 times x and 2 times 3. So 2x plus 6. Again, on the bottom we have 20x squared. That's that common denominator that we found. 2 times 5 times 2 is 20, and then x squared. Now, do not start going crazy here and canceling things out. I know it's tempting to go, oh, look, 5 goes into 20 and we can divide, and yeah, that's fantastic, but then you're going to end up right back to the first problem that we started with. So instead, at this point, we're just going to take and we're going to do 5x plus 2x plus 6, just like before. So we have our common denominator, 5x plus 2x plus 6, which equals 7x plus 6 over 20x squared. So this does not simplify any further because 7x plus 6 would not have any factorable terms. So there's no greatest common factor. It doesn't factor anymore. But we do want to include any values that don't work for x. So looking at the current problem, we have this x squared. So that means x can't be equal to 0. And if we look back at any of the other denominators and any of the other fractions, here, here, up here, the only value we have is x. So x can just not be 0. And that right there would be our simplified expression. Okay, so let's try another one, number 4. So this time we have two binomials, and actually number 4 is one of the easier ones. Number 4 is a little bit more challenging because of those monomials. So what we're going to think of is, okay, we need to figure out our least common denominator. So we have x plus 1 on this one, and over x, plus, here we have x plus 2, and we have 3 on top. Now, in order for them to be the exact same, this first fraction, this x plus 1, is missing the x plus 2. Okay, our least common denominator would be x plus 1 times x plus 2. That's what we need. We need both of those factors. So we would have to simply add in an x plus 2 here on the bottom. And if we put it on the bottom, we have to put it on the top. Now, our second fraction is missing the x plus 1. So we're going to put x plus 1. And same thing here. We've got to keep this. We can't change its value, so we have to put it on top. Now, we are going to multiply the tops, but we are not going to multiply the bottoms. We are going to leave the bottom as x plus 1 times x plus 2. We're not going to change that. There's no reason to have to multiply that out, okay? But we do have to multiply the top because we are adding the top. So we have this x times x, which is x squared plus 2x. Here we have, now this is adding, so we have 3 times x and 3 times 1. Okay, and again, the only reason we're multiplying the tops is because we need to combine the tops. So we have x squared plus 5x plus 3. Now, again, the reason we're not multiplying the bottom is because we want to see if there's any factors that are going to cancel. Because x squared plus 5x plus 3, there are no factors of 3 that will add to 5, which means this cannot be simplified anymore. But you don't have to multiply the denominators. There's no need to do that. But we do need to say what x cannot equal. So looking down here, x cannot equal -1 and -2. And if you look anywhere in the previous problems, you can see those are the same throughout. So that's one nice thing about adding and subtracting is, generally speaking, you don't lose too many terms. Okay, you don't lose those restrictions too often. All right, number 5. All right, so number 5 is a little different in the fact that we're going to have to do some factoring. So if I was going to sit down and factor this, so again, thinking back through my LCD, this would be 7 over 9 is 3 times 3, and then x times x, plus x, let's see, that would be 3x that comes out, giving us x plus 1. So if we're looking for our least common denominator, well, notice here we have a 3 in common and we have an x in common. We only write that down once. So we have 3x, but then I need this missing 3x. So I need this guy here and this guy here, plus I need that x plus 1. So my least common denominator is going to be 9x squared times x plus 1. So that's what the denominator is going to look like when we're done. So we got to figure out what we're lacking here in order to simplify this down. So this first fraction, it looks like the only thing he's missing is this x plus 1. So if we put x plus 1 here, notice they already have the 3x and the 3x. Now the second fraction is missing one of the 3x's. Okay, and you can see that because that's not what's highlighted here. So we're going to multiply the top and bottom by 3x. So on top, we're going to have 7x plus 7 over, now remember 3x, so we have 9x squared times x plus 1, which should be our least common denominator, plus 3x times x is 3x squared, and again 3x times 3x is 9x squared times x plus 1. And now it's a matter of adding these top, so we have this here, we're just going to add the top. So we're going to have 3x squared plus 7x plus 7 all over, and we keep the denominator. And we always keep the denominator. So we can look and make sure that this top doesn't factor. Remember, to do that, we would use our discriminant. So I'm not sure if it does or not. So let's see, we have 7 squared minus 4 times 3 times 7. So 49 minus, what is that, 28 times 3, 84. So that equals -35. So because that's an imaginary discriminant, this is not going to factor. So we know that this right here is our final simplification, but we do want to include what x cannot equal. So remember, for here, this x squared, x can equal 0. For x plus 1, x can equal negative 1. Remember, in case you've forgotten, you just let the bottom equal 0 and solve. So 9x squared can equal 0, x plus 1 can equal 0. Okay? All right, let's try number 6. So number 6, again, we're going to start by factoring the denominators completely. So I have this x plus 2. 2x minus 2 is 2 times x minus 1. Now, I really don't like working with minuses here, okay? It's because we tend to make mistakes. So instead of making this minus, I'm going to make this a plus. And to make that a plus, that means I'm going to have to distribute my negative to both of those terms. So I'm going to write that as 2x plus 1. Okay, and that's just going to save me some pain in the future, okay? Now, we do need to factor the denominator. So this would be x minus 3 times x minus 1. So again, thinking through our least common denominator, we need a 2 and an x minus 1. We'll notice that that's something they have in common. They have the x minus 1 in common. So the only thing else we need is the x minus 3. So this first 2 times x minus 1 is missing the x minus 3. So we're going to need x minus 3 on top and on bottom. And the second one is missing the 2. So we're going to have 2 on top and bottom. So now we're going to multiply, okay, only the numerator. So we're going to distribute this out. So x squared minus 3x plus 2x minus 6. We're going to leave this as 2 times x minus 1. Please do not do extra work. You want to leave it like that. Plus, again distributing, so 4x plus 2 over 2 times x minus 1 times x minus 3. Now again, it doesn't matter which order the factors come in so long as the 2 is in the front. So you could do x minus 3 first or x minus 1 first. So now we're going to take and we're going to add these numerators. So we have an x squared. Whoa. Let's see, we have negative 1 plus 4, so that's plus 3x. Negative 6 plus 2 is negative 4. Now, we're going to check to see if our numerator factors, and in this case it does, because I'd have x plus 4 and x minus 1. That would add to 3x. So notice in this case, we actually are able to simplify this down further because we have these here, this x minus 1 in common. So those two things are going to cancel, and we're going to be left with x plus 4 in the numerator over 2 times x minus 3 in the denominator. Now again, we're going to include what x cannot equal. So in this case, x cannot equal, of course, 3, but it also can equal 1 from our previous denominator. Okay? So make sure you include both of those. And that right there would be our answer. So I'd like for you to go ahead and try number 7, see what you can do with it, and then turn the video back on. Alright, so the answer to number 7 is x squared minus 7x minus 14 all over x plus 2 squared times x minus 2, such that x cannot equal positive or negative 2. Now, a couple of things here. You do not have to put x plus 2 squared. Know that it will typically be written that on a multiple choice or multiple select type of question. Just because it's a little more simplified, there's not as many things to write. And honestly, mathematicians are a little lazy sometimes, so that's a shortcut. If you write x plus 2 times x plus 2 times x minus 2, that is still correct, okay? The other thing is you should have checked to see if the numerator did simplify, and I did, and it did not. So the discriminant was negative. Maybe it wasn't negative, but it wasn't a perfect square. So it didn't work there, so I couldn't factor it any further, which means this is our final answer. Okay, so hopefully you got that one right. If not, make sure you go through and see what I did. Notice the green is what I multiplied each fraction by, and then make sure you have added and subtracted correctly. Okay, that's the end of this video.